Welcome to this lecture on the rectangular coordinate system. Again, you should be familiar with virtually everything that we're going to do in this lecture, so it's somewhat of a review. Let's start out with quadrants and points, and we're going to graph these points here, 1, 5, 2, -4, -3, -2, and so on, and on graphing paper. So I'm going to go over to Paint. Oops, I think I accidentally got myself back to Word. Let's see. Oops, there it is. Okay. Let's see. What did we say? For example, 1 and 5. 1 over, 5 up, and there's the point. -2 and 4. So -2 and 4. There's the point. Of course, we call these your quadrants. It's quadrant 1, quadrant 2, quadrant 3, quadrant 4, and as we'll figure that quadrant 1 is positive for both x and y, quadrant 2 is negative for x and positive for y. Let's see what happens in quadrant 3, -3 and -2. So here it's both negative, quadrant 3 is negative for both x and y. And then we have 1.5 and -4, so 1.5 over and -4 right there. So quadrant 4 is positive for x and negative for y. And we're pretty much familiar with that anyway. 3 and 0 means, of course, 3 over, and then we'll stay on the x-axis because the y is 0. And then 0 and -2, which means we stay on the y-axis because the x is 0, and then we go 2 down. And these are pretty much the points, and I think that's straightforward. I'll copy the image later on into Word when I'm done. Okay, let's go back to Word and see what we have next. Graphing examples. A line of 2x minus 3y equals 6, a parabola of y equals x minus 4 squared minus 3, and a circle of x squared plus y squared equals 16. How do we graph them? Well, one way for me would be to say that I graph the y-intercept, for example. The y-intercept where x equals 0. So I'm going to leave this out, and I'm going to have -3y equals 6. And I have y equals -2. And I'm going to write that down. Y -2 is the y-intercept, and then the x-intercept I have at 2x equals 6, so x is going to come out to 3 for the x-intercept, and so that's how I'm going to graph that line. The parabola will graph at that it shifted down by 3, and then shifted to the right by 4. Notice that it says -4 here, but actually that minus needs to be there, and then the 4 here is positive, so it's shifted to the right by 4 and 3 down. The circle is centered at the origin, and it has a radius of 4. Again, I'm not going to get into much detail here because you should be familiar with that from previous classes. I'm going to go over to Paint, and I'm going to kind of graph them there. And I'm going to go to a graphing calculator and graph them on the graphing calculator. Okay, let's go over for Paint first. So let's see. Okay, I said that for the line I have x equals -2. There's the x-intercept. And x equals 3, there's the, I'm sorry, that was the y-intercept. This is the x-intercept. And I'm going to come up with a line for these 2 points. So there we go. There we go. So here's our line. For the parabola, as I said, it should be shift it 3 down, and then 4 to the right. So this should be the vertex of the parabola, and then I'm going to try to sketch the parabola. It's always a little bit tricky. Well, it was a little steep here. It's not like that here. Not perfect, but not too bad either. It'll look better on the graphing calculator. And then the circle, and this one here might work okay. Let's see, I know I have a radius of 4. So there's the circle. That's how they should look like. Let's go to the graphing calculator in just a moment. First of all, I'll go back to Word, and I have to say that on the graphing calculator, we have to write things in Y. We cannot type in 2x minus 3y equals 6, but we have to say y equals. So we solve for y. Well, it's going to be 6 minus 2x. Then we divide by -3, so we're going to have 2/3 x minus 2. Should be correct. I'm going to double check that. Yep, that's correct. So that's what we need to graph, and I'm going to write this down here for me so I won't forget. X minus 2. There we go. The parabola we can just type in like we have it here, and the circle. Well, again, we have to solve for y. So I'm going to borrow myself something. I actually have to search for it, unfortunately. I'll be right there if I find my cursor. There we go. Okay, this is not going to be the limit, but I'm going to write y equals in the equation editor. You see a little gray box here. I actually see lots of symbols in there, but for some reason it doesn't show on eLive when I record that. I have to solve for y, so it's going to be 16 minus x squared, and then take the square root. So 16 minus x squared, and that's what I have to type, and respectively when I take the square root, I can come up with plus minus. There we go. So that's what I would have to type in respectively. I have to do it twice. Let's go over to the graphing calculator and do all these, and they should look really similar to what we have, what we just graphed in Paint. So I'm going to go to y equals, and the first one we had was 2/3 x minus 2, and I graphed that, and that's pretty much the line that we had. Y-intercept at -2, x-intercept at +3. I like to save this one respectively. I like to click on zoom and make a zoom square. The two axes in the graphing calculator are not to scale, but the z-square makes them to scale. I'll save this here, this image here, so that I can paste it later into Word. Let's try another one. Y equals, and this will be the parabola, where y equals x minus 4 squared minus 3. You can also see that this is kind of an introduction to the graphing calculator, that we've become a little bit familiar with it, and that you can see how to use it. I click on graph. Notice that both of these are highlighted, which means both of them will graph. There's the parabola. If we only want to see one, we go back, de-highlight the first one. We could clear it, but I like to just de-highlight it and then graph, and there's only the parabola. And as we had mentioned earlier, the vertex here is at -3 and +4. Again, I like to save this one. And the last one is going to be, let's de-highlight the parabola, is going to be the square root of 16 minus x squared. And when we do that, we only get the upper half of the circle. Well, as we take the square root, we also get a negative solution, so negative square root of 16 minus x squared. You see that's a little bit cumbersome. And then the graphing calculator doesn't have the absolute best resolution, so it leaves a little bit of a gap here. In any case, the 3 that I just showed in the graphing calculator, that's the same as we had drawn in Paint. Let's go back to Word and see what we'll talk about next. Distance formula. Determine the distance between 2, 1, and negative 1 and 5. Let's go to Paint and see how we can do that. So I'm going to paint in here the 2 points, 2 and 1, so 2 to the right, 1 up. By the way, if this is a little bit off the screen for you, just shift on the scroll bar, shift it to the right because you should be able to see what I'm seeing. And negative 1 and 5, so this one here. And then the distance between those two is this here. How do we come up with the distance? Well, relatively easy. We just take the difference between the x coordinates, which comes out to 3. That would be 2 minus negative 1, which is 3. And then we take the difference between the 2 y coordinates, which means 5 minus 1, of course, comes out to 4, as we can see. So we have 3 here, we have 4 here, and we have a nice Pythagorean triangle. And to determine the distance in the coordinate graph, just use the Pythagorean theorem. So that we have 3 squared plus 4 squared equals the hypotenuse. We're familiar with those numbers. Take the square root of 16 plus 9, so that square root of 25 is 5. The distance comes out to 5. V equals 5. And I'm going to go back to Word. So the distance equals the square root. I think I'm just going to use this one here. I like to copy and paste these things here because it's really quicker for me. Oops. Don't do this. Distance. It puts the tangent in there automatically. Oh well. Distance equals the square root of the difference between the two, which was 3 squared plus 4 squared, which of course is square root of 25, which comes out to 5. Okay. Some important angles we have to look at, and they will start becoming important already in the next section. Those angles are 0 degrees, as the show line, this is line, blue line shows here, 30 degrees, and you can remeasure that with a protractor, 45 degrees, that's easy to see as it bisects the squares, the diagonal of the squares, 60 degrees, 90 degrees, and 180 degrees. There are also other angles in between here, such as 135 degrees, such as 120 degrees, and in the third quadrant and the fourth quadrant. But most of the time we'll be talking about the acute angles for any one of the quadrants, respectively the reference angles, as we will name them soon. With that, I conclude this lecture.